Okay, so let's go over some examples right quick here. The first being oxidizing using KMNO4 and KOH. We're again highly basic conditions under high heat, and that heat sign, that delta being there. And then just neutralizing with H+. So you can pretty much bet the ranch that there's going to be some kind of carboxylic acid that's going to form as a result. Okay, so it's going to be how to neutralize your intermediate into an organic product. So it's going to need, again, an acid workup. So what you're going to get from that is a ketone. Remember, if there's already that methyl group that's sticking off of there, that can't be oxidized with it. The double bond is going to be oxidized. So in other words, you're going to see a conversion of a ketone on one end and then a full oxidation to a carboxylate on the right carbon, and then just acidifying to get your carboxylic acid, conjugate acid. Okay, and then B, you're going to have this geminal alkene. So if you treat that with under the same conditions and then do an acid workup, this is going to split off on the top, this one carbon here, and it's going to become CO2. So it's going to become fully oxidized and be a CO2 gas molecule. And then you're also going to have a ketone stemming off of this particular carbon. So that H plus really isn't going to do much for you. Okay. And then for C, sorry, my cat's really distracting me right now. I think I need to put it under sedation or something. Anyway, so part C, we have a tri-substituted alkene. If you could treat it with ozone. Okay, so ozone is going to be highly reactive and actually explosive. So this isn't something you want to just take lightly. Notice that it's also at negative 78 degrees C. So again, you want this at really low temperature. So you would use solid CO2 to keep everything cool. And this is going to be acting as sort of a weak base to keep things moving along here. So you're going to have an aldehyde that is formed. Okay, so remember you have a hydrogen here. At low temperature, that O3 isn't going to oxidize anything any further. So you're going to get this as one of your products. And then the other is just going to be acetone, because you still have those two methyl groups that aren't going to get touched. So in other words, this carbon's going to get oxidized and this carbon's going to get oxidized. Okay, lastly, before I go insane, we have two vinyl groups here that are reacting with O3 and minus 78 degrees C, and then reacting with H2O2 for the second step. Remember that H2O2 is going to be an oxidizing step. So, in other words, we're going to generate carboxylic acid on both sides, and you're going to have two equivalents of CO2 that are going to be generated on both sides, here and here. Okay. Alrighty.